everyone. Now I'm going to explain your sixth lab program. Sixth program will be having A and B. Two programs will be having in sixth. That is implementation of Knapsack problem using sixth A is by using the dynamic programming method and sixth B is by using greedy method. When it comes to greedy method, we already know how the problems are going to be solved in fractional Knapsack, right? While go through this PPT, you just keep the fractional knapsack problem, then you can go through this PPT to understand, right? Import java.util scanner is an header file, and in this program we'll be having two class, that is k object and one more class knapsack greedy. Knapsack greedy should be your file name because this class will be having the main function, right? So k object will be having three data members w, p, r. W indicates weights of the object, P indicates profits, and the R indicates the ratio of these two, P by W, right? Next, when it comes to knapsack greedy, maximum the number of objects that you can give is 20. Next, N indicates the number of object and M indicates the capacity of the knapsack. Next, come to a main function where you are going to enter the number of objects, that a number will be stored in n. Here as an example I have taken n equal to 3. So 3 object is going to be initialized and that is of type k object. So k object will be having a data members, that is p, w and r. So the memory will be allocated for those 3 data members in these two instructions, right? Next, the next instruction in the main function is read object, where in this read object we are going to read the value of M, value of P, value of W, that is nothing but knapsack back capacity. Next, weights of those 3 objects. Next, the profits of those 3 objects. Next, after reading the values, and we are also going to perform the division operation, that is P by W operation. Once we are done with dividing the values, that is going to be stored in R, right? After calculating the ratio of each object, the next step is we are going to sort them according to the values of the ratio. In your problem, after dividing, what you are going to do, you are going to arrange them, right, in a decreasing order. That's the step. Even that is going to be done in read object function itself, right? Next, after that we'll come back and we are going to call knapsack function, where we are going to place the object into a knapsack bag, right? Now we are in read object function, where we are declaring one more variable, that is temp. Temp will be used to sort the values, right? Next, enter the maximum capacity of the knapsack, where we are going to read the M value. In our example, M equal to 20. Next, weights, 0th object weight, first object weight, then the second object weight, that is 18, 15 and 10. Next, enter the profits, that is 0th object profit, first object profit and second object profit, that is 25, 24 and the 15, right? Next, after reading the value of P and W, what is the next step? As I said, we are going to take the ratio P by W, we are going to calculate, and the result is going to be stored in R. The operation is done for 0th object, first object and also for the second object. These two instructions shows how to calculate the ratio for those 3 objects. After that, the next step is sorting step, where we are going to use bubble sort technique, right? So the first for loop indicates the number of passes. The next for loop, J loop, indicates the number of comparison. So compare 0th object ratio with the first object ratio. If the 0th object ratio is less than the first object ratio, what we have to do, with the help of a temp variable, we just need to perform swapping, right? That is what I've shown over here. 0th object value is less than the first object ratio value, So temp will be having 0th object values, that is 25, 18 and 1.38 is placed in temp. Next, the first object values are going to be stored in 0th object. The first object values are placed in 0th object. Next, from temp we have placed the result back to the first step. That is what the swapping we have done over here. I've just shown for only one swapping. Next, once you are done with all the iteration, the final result will be like this: 1.6, 1.5 and 1.38. And one more thing, in your problem, while after arranging them in the order, I've written the values in the table form. While writing like that, what I've done, I've changed the name of the object also, right? If you want to go through that, I've written it as O2 first, next O3, next O1 I've written. But when it comes to a program, it's not going to change the name, but the values are going to be changed, interchange between object 0, 1 and 2, right? Next, we are done with the reading objects. Next, go back to our main function and check what is the next instruction. Next instruction is calling a knapsack function. Next is your knapsack function. When it comes to a knapsack, X indicate a solution vector, right? This is the last column in your problem, right? Next, the total profit, that is your last but one column. Next, I indicates the first column. Next, U is nothing but is your RC. RC is remaining count, right? RC is represented as U in this program. If you want, you can change the name, right? As I said, while solving the problem, RC initially it will be assigned with a value of M. That is what is going to be indicated here. The value of M, knapsack capacity 20, is assigned for U. U is nothing but RC in your problem. Next, total profit is initialized to 0, right? Next, solution vector is also be initialized to 0. For all the three objects in the solution vector, we have initialized 0 value, right? Before going to place the object in the knapsack, these are all the initialization that we need to do, right? Next, for the first iteration, if k object weight, if it is greater than u, in the 0th iteration, if weight of the 0th object, here the weight of the 0th object is 15, is it greater than 20? Condition is false. If the condition is false, we'll go for the else part, right? When it goes to else, the first instruction is, in place of x of 0, we are going to place the value 1. In place of x of 0 in the solution vector, we are going to place the value 1. That indicates we have selected the whole object. Then the next instruction is calculation of total profit. We have just now we have initialized total profit to 0. So 0 plus 0th object profit. That is what I have written over here. 0 plus 24. So total value, total profit is 24. Once we are done with calculating the profit, the next step is we are going to just subtract the weight of the 0th object from knapsack capacity, right? So after that step, you will be having the value 5. Once we are done with the 0th iteration, the solution vector will be like this. Again, for loop, go back, I will be incremented to 1, right? Next, again go to the if statement. First object weight. What is the first object weight? That is 10. Is it greater than u? According to your previous iteration, u value was 5. So, is this 10 is greater than 5? Yes, the condition is true. So, break the statement. When we come out of the for loop, we just need the value of I for the further step. That's why we are just use the print statement to print that I value is 1, right? 1 is less than n. the condition is true, and in your problem you just check the value of x, it must be 1, or some fractional part of the object has to be placed to a knapsack. If you are placing the whole object, that is going to be indicated as 1. If some fraction are going to be, some portion of the object are going to be placed, means that is going to be calculated by RC by weight of that object. That is what we are doing over here. Here, when we come out of the loop, that indicates that particular object doesn't have space to fit into a knapsack. So, some portion of that object has to be placed to a knapsack, right? That portion is going to be calculated over here, that I have shown in this particular statement. That is, the value of u was 5 and the weight of the first object is 10. So 5 divided by 10 is 0.5. So in the solution vector, in the x of 1, we are going to place 0.5. Once we are done with that, next we have to calculate the total profit. Total profit equal to, previously we had 24 plus, now some portion of the object has been selected. So x of 1 into profit of that particular object. X of 1 is 0.5, right? And the profit of that object is 15. Profit of the first object is 15. That is 31.5. Right? 24 plus 7.5 is 31.5. If the first object itself doesn't have space to fit in the knapsack, means there is no need to check for the next object, right? So we'll come out, then we are going to print the solution vector, then it's going to print the total profit. This is your knapsack problem using greedy method, right? And this is what the example I have taken. Enter the number of objects 3, enter the maximum capacity of the knapsack 20, weights are 18, 15, 10, and the profits are 25, 24, 15. Then I equal to 1 is nothing but, as I said, we just need the value of I even if we come out of the for loop, right? That's why we are going to print that. Then once we are done with placing the object into a knapsack, the solution vector will be print and the total profit. This is the first output and this is the second output. So just go through the program. If you have any doubts, let me know and do the tracing. Okay, thank you.